It's basically collecting, not just collecting data, but analyzing data. What does it tell you? Like if I ask you a bunch of questions, or if people poll you and you can't like analyze it or kind of interpret what it's trying to tell you, it's useless, right? So statisticians make a lot of money because they're able to collect data and bring it to life and have diagrams to help us understand it better. Aims to interpret what the data is trying to tell us. So that's it, basically in a nutshell what statistics does. Okay. And here a couple of things to right off the bat to remember is MCTs. What are those? Okay. MCTs. Does that work? Sort of works. Measures of central tendency. Okay, that's what MCTs. And so watch this. It's central, like center, right? So the mean, the median, and the mode attempt to do that. Those are what we call MCTs. Mean is also known as the average. I need you to have that symbol there. The symbol X with a bar on top is also used to refer to the average. Median is the middle number, and mode is the most popular one. We're going to talk about that a bit more later. MCTs, I will just put an arrow like this, tells us where data tends to cluster. Okay, that's the aim of the MCTs, the mean, median, mode. Okay, dispersion. Okay, dispersion or the range how spread out is the data? That's what it's telling us. How does the data deviate from the mean? Deviate is another word another word for it would be differs. How does the data differ? How is it different from the average? Okay. And notice that data is at the center of this. Data is the center, so it could be height, the scores as a percentage, IQ score, number of items, average weight. It could be anything that you collect, right? So data is at the center of this page for a reason, right? You need data to figure out the mean, median, mode. You need data to come up with your range, okay? You need data to figure out the standard deviation. You need data to come up with visual representations, which we will graph. We will actually graph that. Okay. So everything surrounding data, right? Yeah, but we need data first and foremost to be able to do everything around it. Okay. Standard deviation. Can you put this symbol? It's actually sigma like this. It's like a circle with a little squiggly on the top. Like put that down so you're not surprised when it comes your way. This is a very important one to me. Okay, standard deviation. It basically tells us how spread out data is. Okay, how spread out is it? Is it spread out or is it closer together? That's what standard deviation tells us. How much data deviates from the mean? That's another way of, it tells us two things, right? So you can put a bullet actually for each line because it tells us two things, okay? And so then we'll also move on to visual representations. So there are four ways to visually represent and organize, right? I'll put down an arrow here, organizes data. That's why we tried to graph it, because we want to organize it so it can tell us something. So once we've talked about the four, the most important, the last thing will be the normal distribution curve. And it's actually a bell curve. So can you just have a straight line? It's going to be like our x-axis here. And along the x-axis, we're going to try to find somewhere in the middle, just make a line like this. Okay? And that is going to be known as our average. Put the x with a little bar on top. That's what we know as average. So if something is normally distributed, if we were to put points down here, put a point, just follow this and go a little higher up here and make a dot. That's going to be kind of like representing the highest point. And then we'll make a hat out of that. Watch this. We go down like this, but never touching the x-axis. You do the same thing on the other side. You try to mimic. A normal distribution curve. And you can actually make a line like this if you like. And this is called a bell curve. A lot of things in nature follow a bell curve. If you collect data and then you graph it, it will have a bell curve. Some examples, geese arriving in the spring. Some geese will come super early and then more and more come, but there will be a date where most of the geese come, right? And then there's still some that come later and later and later, but that's not, the number decreases over time, right? So that's same with rush hour, right? What's rush hour in Winnipeg? It's about 5 o'clock, right? Just after 5. But there's this sweet spot where, let's say we sit down at an intersection. You'll get a few cars, right? And then it will build up to a certain peak time. And then it will slowly decrease as well, right? So a lot of things are normally distributed. Same with the height of people. Like if we were to take the average height of Canadians, right? There would be people on the left side. There'd be me way out here probably somewhere, right? Because I'm much taller than the average. But we would have the average where most people fall into. And some people will be taller, some people will be shorter, right? So same thing with weight. A lot of things would follow a normal distribution curve. When I look at my test scores, quite often it's a bell curve, right? I have my average where most students fall, and some are here, some are there. Not always. Sometimes my curves do not look like bell curves at all, right? Sometimes you have this, and this, or something like that. Like, so not always is there a bell curve, but quite often we will notice that there is a bell curve. So this is when something is normally distributed. Okay. Let's dive in and do a little bit of further exploration here. Let's talk about mean, median, mode. And yeah, I'm going to highlight a few things here and there, so have that ready as well. A measure of central tendency is a number around which the data clusters. Okay. I'm saying the same thing again. In mathematics, there are several different measures of central tendency. The most common is the arithmetic mean, usually called average, right, in everyday language. And so here it is. Do we need to close that blind over there? Or can you see well? That side of the room, can you see, John? Yeah. So there's the mean, which is x with a bar, most common, or mu. It's another letter. So sometimes some textbooks use this, but don't worry about that. 99% of the time it's like this. The arithmetic mean is denoted by the symbol x bar. It's found by adding all the values and then dividing this sum by the number of values in a set. Make sure you include units, but here's the formula in a nutshell. You probably have never been given this formula, but it goes like this. Sum of all values divided by the number of values. Have you seen this symbol before? The sum, sigma. Okay, like this tells you that add everything up. That's what that letter represents. So I will just put an arrow. Okay, this is the sum of all data, and n represents the number of data points that have been considered, right? Our calculators are going to be great help in this. Median. Median is the set of all numbers. Of the set of all numbers, it's the middle value of the data set. It is most easily found when numbers are listed in ascending or descending order. Okay. Half of the values are going to be above and half of them are going to be below. That's the key about the median. Okay. Government often talks about the median household income, right? They'll say the median income for families is $50,000, which means that half of the families will be making less, a little bit, so. And half of the families will be earning more, right? Or the median score on a test, 60%. That means that 60% of students scored below 60%, half of the students scored above 60%, right? If there's an even number of values in the data set, the median is the average or the mean of the two middle numbers. Okay, so I'll give you an example here. So let's say we have a data set that's already arranged 2, 3, 5, 11, 16. This would be odd, right? We have 5 values, so that right there is our median. I will just put units so we get used to that. But what if we had a set that is 2, 3, 5, 11, 16, 21? Let me zoom in a bit. I think I can do much better than that. There we go. So this is even, right? So these two numbers will give us the median. Okay? So in this case, the median would be 5 plus 11 divided by 2. Like you're finding the number that's right in the middle between 5 and 11. Make sure you have brackets at the top. So it'd be 16 divided by 2. So this would be 8 units. So that's how one thing to just keep in mind. If median is there, if it's asked of you, sometimes it's a number in the data set. Sometimes it's actually a number you calculate that is in between the two middle numbers. Okay. Mode is the number that occurs most often in the list. and it's usually also known as the most popular, right? You could have no mode if each number appears the same number of times. So if you have 3, 3, 4, 4, 5, 5, 11, 11, right? So you're like, hey, it shows up 2 times, but everything else shows up 2 times as well. So in this case, there's no mode. Or you could say mode is equal to not applicable. Don't put down 0, because then you're telling me that the mode is 0, right? The most popular number is 0. So don't do that, okay? Just say that there is no mode or not applicable. One mode is if one number occurs most often than the other. So 2, 2, 3, 3, 5, 5, 5, 6, 9, 14, let's say. So it's already arranged. Notice that when you arrange things, it's much easier to find things. And that's your mode right there. The mode is 5 units. It could be dollars, it could be minutes, hours, centimeters, inches, feet, you name it. Okay. There could be a number of modes if 2 or more numbers occur the same number of times. And this is the greatest number of times an entry occurs in the data set. So let's say you have -3, 0, 1, 1, 1, 7, 12, 13, 13, 13, 17, let's say. Oh, you're bringing in negatives? Sure. So you notice that there are 3 ones. Oh, I should, you know what? Can I do this here? Just to make sure you understand, let's put a 17 there. So you notice that there are 3 ones, so clearly a winner, right? Compared to everything else, because there's 2 17s, but it loses, right? One shows up one more time, so 3 times. But there's also 13 that shows up 3 times. So there's a tie between these two. So in this case, you would say mode is 1, 13 units, right? 1 or 13. It would be the mode there. So not very useful in that case. The mode would not be very useful to figure out like the middle. I'll say this here. Although the mode is referred to a measure of central tendency, it does not necessarily lie towards the center of the list. Okay, the mode, it does not necessarily lie towards the center of the list. The mode is used in different situations than the mean or median. For example, a store owner could use the mode to find out the size of t-shirts that is most popular and use this information to decide how many t-shirts of each size to order in the future. The mean and the median wouldn't help the store owner make this decision, right? What's the average t-shirt size? Oh, I'm going to just order large, all of them large, right? That wouldn't really help you a whole lot, right? You would base it a bit more on the mode, like which sizes do I sell more of in that case. Range, not an MCT, watch that. It is calculated by subtracting, right? Subtract the smallest from the largest. It is a measure of dispersion, which tells us, right? Tells us how spread out the data points are. Just remember, the bigger the range, the more spread out your data is, because the max and the min are further apart, right? So keep that in mind. Outlier or outliers, a value or values that are significantly different from the general, right? Significantly different from the general trend. Outliers cause the mean to either increase or decrease. Outliers also affect the range of the data, right? Outliers skew the data. Uh, it causes a bias, right? So outliers often skew or alter or doesn't really give the correct picture. Right? So if a student, for example, when I enter my marks for a test and I enter a 0, but that's due to the student not having been here, I would probably not say that that's accurate, right? My average would be really affected by it, right? So let's say my average is 70 for the class. I enter that 0, it goes down to 65. That's considered an outlier, right? So quite often outliers cause the average to be affected either case, or up or down. Right? So let's keep going. A lot of information. I understand that. And this page, I will come back to quite often. So this is a very important page to me. Standard deviation, we will also refer to it as just SD, right? Standard deviation, which has that symbol or sigma, measures the dispersion, right? Make sure you highlight that. Measures the dispersion or variation within data points around their mean. Put simply, the standard deviation is the average distance from the mean of all data points in the set. This can be calculated and will have the same units as data set. Okay. So before we, can I just tell you something right now today? This is going to be a little bit of, what? This is gibberish, Mr. Dirksen. I don't understand this. So just take it as this is the first time I talk about it, but I will talk about this a bunch of times down the road. So try to wrap your head around. Let's go back to this. The standard deviation is the average distance from the mean of all the data points. So on average, how far are all the points from the mean, right? So here we go. A lower standard deviation generally indicates that the range will be low as well. The data points are closer to the mean. The data is clustered around the mean. The data is also known to be consistent, mostly closer to the mean, a few or no outliers. And the graph will show a steeper curve. So like most of the points are gathered inside here, right? So you're collecting points, and so most of them are gathered, right? They're consistent. If this is your average, most of them are clustered, right? Clustered. That's what you want as a teacher, that most of your tests are closer to the average. So you understand, okay, like most students understood the same amount of concepts that you taught. Now I can probably work with this group and bring you higher up on the average, right? Can like make you be better at it. But you're all kind of understanding the same thing. It's not like all over the place, right? So this would have a low standard deviation, right? Everything is clustered. And remember, the range between the lowest and the highest value would be smaller as well, okay? Next, what if you have a high standard deviation? Remember, it's actually going to be a number in a bit for us. A high standard deviation will be that the range is greater. The data points are spread out widely, right? The data is scattered further from the mean. Therefore, it's less consistent, may have multiple outliers, and the graph will be flatter, right? So you have like points all over the place. Maybe a little bit more, if every point represents data you're collecting, right? And you'll have a lot of outliers, so everything is spread out all over the place, okay? Look at my curve. Doesn't it look atrocious, right? That's because I tried to graph on the software and I just couldn't. It should be smooth, right? But you get the point. You get the point. Okay. Um, so this is going to be basically the meat and potatoes of this unit. Understanding this isn't going to cover everything, but this slide right here will kind of summarize everything. And notice that the range is connected to the standard deviation, right? So if the standard deviation is high, right, the range will also be greater. Okay. If this standard deviation up here is low, the range will show that as well. They go hand in hand. Okay, they go hand in hand. Standard deviation and range go hand in hand. Okay, this will be consistent. This will be inconsistent. Okay. All right. Let's keep going. This is where we use our calculator extensively, so make sure it's charged. Okay, using the graphing calculator to find the MCT, standard deviation, and range. I'll show you that in a bit how I actually do that. When we enter data into L1, you know how to do that already. Remember from quadratics? Maybe I'll have my calculator. Maybe have yours out. And let's just refresh how we get there, right? You go stat, edit. Oh, I need to clear all my stuff here. Enter data into L1. Can we do that right away? I'm gonna skip down. Can you enter this into L1 right here? Toronto's average temperatures for April. Let's enter that together. Okay, so 5, enter 5. I have 12 values. I'm always counting 2, 4, 6, 8, 10, 12. I entered 12. I'm just going to do a check so that I don't mess everything up for this lesson. 8, 5, 5. Okay. So let's kind of walk through these steps. Enter data points into L1. We did that. Sort the data. How do you do that? You press stat again. And before we haven't used it, but it's sort A or sort D. What do you think A stands for? Sort in ascending order or descending order, whatever you want. I always go with ascending order. So you go enter, and then it's asking you which one do you want me to sort. You got to go second one, right? You're going to tell sort to use L1. I don't close the bracket, I just hit enter. When it says done, let's just go check if that actually happened, right? Stat edit, L1 is now arranged from smallest to greatest. Isn't that cool? Thank you very much, calculator, right? So that's all arranged. And I'll tell you why that is important in a bit. But now I want to tell you the best part about this calculator. If you press stat and you go to calculate. You see at the top there? And you're like, I'm going to use quadratic regression. Nope, you're not going to use that one. You're going to use one variable stats. Can I just say something? We will not use two variable stats in this course. Never. So it's always one variable statistics. You hit enter, and then you're going to go second one for L1, right? You're going to feed it L1. And then hit enter. And right there, what just happened is it gives us the average. It gives us the standard deviation, how many values were used. It gives us the smallest value, which is 0. Let's keep scrolling down. It gives you the median. You see that? Median? Keep scrolling down. It gives you the greatest value, which is 12. And that's basically it. That's all the data that we will use from it. So let me just say this. This right here is the mean or average. I don't really use these two here. I don't. I use this one here, which is the standard deviation. This just tells us number of data points. There are 12 points that we're using. And so, sorry, there's some overlap, but this is the lowest value. Lowest value. And this is the greatest value. And this is your median, obviously, right? So I'm going to highlight the important ones, right? I'm not going to use all of them. I'm just going to use the ones that I really need, okay? So just to reiterate, these numbers have nothing to do with the one we just entered, right? We got completely different numbers. I just wanted something on the screen or on this paper to help you figure it out. Find the range by subtracting max x minus min x, okay? So the range is max x is 9 minus min x is negative 12. Watch the double negatives, right? And so this is really 9 plus 12, right? It's a 21 units. Okay. Determine the mode or the modes by looking at L1, which is now sorted. I'm not going to go through it because we don't have them. Like right now, we don't know what the data is that was used to come up with these points, right? But this is just how you would find the mode. And maybe we'll just leave that at that. So if you use one variable stats, okay, that's probably, for me right now, very important that you know to use one variable stats because it gives you everything, the MCTs, right? And obviously know how to sort, right? But make sure you know how to access one variable stats, statistics. Okay. All right, so we're gonna we're going to work with these two here. Below are the daily highs over 12-day periods for April in two cities of Canada. There's Toronto, there's Winnipeg. For Toronto, let's figure out the mean, median, and mode. So we entered this into L1. We already did that. We're going to go over to this page here. And so we're going to do Toronto, right? So one variable stats, L1 for Toronto. So we're going to come up with the mean. What's the mean for Toronto again? I'm going to turn on my calculator. I still have that there. As soon as you do anything, guys, if you press enter again, it will redo it for you. But there it is. So it's 6.83 degrees Celsius. Then I skip down to the, it doesn't ask me for standard deviation. So I'm just going to skip that for now. Median. The median is, scroll down on your calculator, it says 7.5 right there. It's asking me for the mode as well. Before I do mode, I will do the range. What's my range? How would I find that? Glad you asked. I'm just going to go, the maximum is 12 minus the minimum is 0, right? Min x is 0. So 12 minus 0, there's a 12-degree range. Between the highest and the lowest temperature, it's 12. Can I ask you to write down the standard deviation as well, right underneath it? It doesn't ask for it, but it doesn't hurt. Where's the standard deviation again? Which one is it? It's this one. It's this one right here, not that one. It's this one, right, with the sigma symbol. So it's 3.21 what? Still degrees Celsius. We're going to see how the standard deviation is related to the range. In itself, it doesn't help us a whole lot, but when we compare it to a different city, you should see how they are related. Okay? You're like, what about the mode, Mr. Dirksen? Second, do you need to quit? No, I don't need to quit. I just need to press Stat, Edit, and go through your list and find the mode. I'm gonna. Is that better? Okay. Anyways. So I've got 3 5s there. So that's definitely a candidate. There's 3 9s. And that's it. So it's actually 5 and 9, right? My modes are 5 and 9. 5 and 9 degrees Celsius. I don't like to go, I'm just going to leave it like that. Okay, both appear 3 times. Let's do Winnipeg right next to it. And here's a little trick. It's not a big trick, but I will go 1 var stats. But I'm going to type this into L2. I don't want to erase the first data sets that I have. So what I'm going to do is I'm going to go to L2 and type in Winnipeg's information. So let's go just to the previous page here and enter this into L2. Just going to check if I got it right. Yep. So I'm putting on my paper here L2, that you know, right? Why am I using L2? Because I'm typing that into L2. Before I even do anything, I'm going to go sort. I'm going to sort it. So stat, right? And then go to sort A. I'm going to go second 2 to call L2. Sort it right away before I do anything else. That helps me later on with the mode. Then go stat, calculate, one variable stat, second 2 for L2, and there you have it. So my mean temperature is 0.5. My median, I'm going to figure that out. My median is 1.5 right there. My mode to be determined. My range, I'm going to figure that out right now because I can use my calculator for that. So I'm going to go max is 9 minus the min is negative 12, right? So that is really 9 plus 12, which is 21 degrees Celsius. Oh, wait. Why did I put 0.5? What's happening? That's 6.02, right? Or did you guys get, am I doing something wrong here? Hold on. Is it 6.02? Is that what you guys are getting? I think I pressed something. Let me try again. Oh, it is 0.5. So I got everything else wrong, right? Or no? The median? 1.5, that's good. And it's 9 minus negative 12. Okay, so I don't know what happened. I guess I just, yeah, I scrolled down, that's why. So average is still 0.5, we're good. The mode, let's go to stat, edit. I'm going to go to the L2 here and look for a mode. There are 2 6s there. Nothing else is showing up twice. So that's your mode. Shows up twice. Let's do this. Shows up twice. Show up 3 times. Maybe let's do that. And the last one is standard deviation, or this, right? I'm going to bring that back. My standard deviation, as you notice, is 5.77 degrees Celsius. Do you notice a relationship between the standard deviation and the resulting ranges, right? A lower standard deviation, we have a lower range compared to on Winnipeg side, there's a higher standard deviation and therefore a higher range. I need you to see that. Like if you see that today, you're doing pretty good. Would it make sense as well? Winnipeg's temperatures all over the place, right? They're a bit more scattered, right? They're like super low and then super high. Like it's not Toronto's. Toronto's temperatures are a little bit more clustered. If we were to draw the curve for each one of these, this one would have a steeper curve. This one would be flatter because of it's spread out more. Okay. So spread out more. Low standard, greater standard deviation. Therefore, data is more spread out. You can add that to your notes. That'd be great. Okay. So we found the MCTs. Those are the first 3. And then I asked you to find the range standard deviation as well, just to compare them. Okay. Here is the other reason why arranging your data is great. Creating line plots. for the temperatures in both cities. Label the mean, median, and mode. And these are the steps you should take, right? Use the min and max to determine your scale. Add labels and units. Place data points on the line. Stack if there are multiple entries. This is important. That is actually, those are going to be potentially your mode, right? Is going to come out of those. Label location of MCTs. Range is not an MCT, right? So let's try that. I'm going to ask you for this purpose we're going to use the same scale. Okay, I'm going to start from -16, and I think I'm going to go up by 3 degrees. So we're going to go -13, -10, -7, -4, -1, 2, 5, 8, 11, 14. We're going to put arrowheads on this is technically an x-axis. Okay, and we will call this Toronto temps, right? Temperatures in degrees Celsius. And we'll do the same thing for Winnipeg, same scale. I think it just works nicer to show the difference. These are Winnipeg temperatures, also in degrees Celsius. So you have a scale, you have label. Now grab your calculator. I know I have Toronto, Winnipeg already printed there. I know that. I saw that, but I think I just want you to go through the steps, right, and label it. Now grab your calculator, and I'm going to go stat, edit, and I'm going to focus on Toronto first. So if it's a range, it's super easy to just plot them, right? So 0 would be, you can use dots, you can use X's, it's up to you. But 0 is right there, right about there. 3 is right about there. So you use your calculator, right? And then there are 3 5s. So you go 5, 5, 5. You stack them like that. Then you have a 7. Then you have an 8. You have 3 9s. So 1, 2, 3. You have a 10 and a 12. So this is what Toronto's line plot looks like. So I basically just go by the numbers and put them where they should be going approximately. Okay. Then I will do the same thing for Winnipeg. Go over to it's already arranged. So you go -12, -7, -5, -1, 0, 1, 2, 3, 4, 6, and 6. There are 2 days where it was 6 degrees, and a 9. Can you see that one will have a flatter curve compared to the other one? You should see that, right? This one will be a bit more, it's more clustered as well compared to this one. This one had a higher range. This one has a smaller range, which you should also see. This one has a low standard deviation, a high standard deviation, right? So there's a relationship there. But we aren't done yet. We're supposed to label mean, median, and mode. Okay, so these two would be the mode, right? The average, I just go by, it's 6.83. Okay, right there is your average, which is 6.83. We already know what the units are, so it's okay to just do that. And your median, what was our median again? 7.5. It's between 7 and 8. Okay, so our median goes right there. It's between 7 and 8, right? It's 7.5. So just kind of approximately tell me where that would be. And we do the same thing for Winnipeg. Okay, let's do the average is 0.5. This is 1, and 0.5 is right about there. Oops. So it's not, try your best to make it, to place it where it's supposed to be. But the average is right there, which is 0.5. The mode is right here. There's only one mode, which is 6 degrees Celsius. And the median is 1.5. So the median is somewhere in there between 1 and 2, right? I would want to say this too, that this one right here would be considered an outlier. It's not an MCT, it's not that, but it does affect your range. If we were to remove this one, your data would not be as spread out as you including that one. Okay. I just want to add this, if you don't mind. It's a little bit work, but the range is 12 degrees and the standard deviation is 3.21 degrees Celsius. The range for Winnipeg is 21 degrees Celsius and the standard deviation is 5.77. How about we box that in, because it's just, you don't need to add that to your line plot, but because you already have that information, it's nice to put that in. Yikes. Anyways, Toronto. We're going to describe both of them using the MCTs. Greater mean indicates that it is warmer than Winnipeg on average. Range and standard deviation are smaller, comma, which means that most days are most temperatures are closer to the mean compared to Winnipeg. uh, data is more consistent. So I'm going to erase the Toronto part here, okay? Because this summarizes it for both. Summarizes it for both. So I guess I just have to say Toronto has a greater mean indicates that it is warmer than Winnipeg on average. No, you know what? Toronto needs to stay there. It feels like a Monday. Sorry, guys. Toronto needs to stay there because I'm basing it on Toronto. But you can basically reverse this and talk about Winnipeg just in the opposite way. Okay. Have a good one, guys. No homework today.